All right, object-oriented programming, sometimes called OOPS, as you'll hear people talk about, is a different paradigm of programming. It's a different style of programming compared to scripting. So we've been primarily doing functional programming, doing scripting programming, thinking about code as living in one notebook, one file, one script, and you run it top to down, and that's what your program is. It runs one thing after another in a stepwise function. In reality, that doesn't really work for very complex programs. So when you think about things like Facebook, when you think about things like Instagram, we can't have every piece of code on Instagram running as a one line script. We have to start thinking about things in a more abstract way. So on Facebook, they have users, and users have friends, and then there are administrators, and there are groups, and there are postings. And we start to think of these things as concepts or objects. And then we start to program around those concepts and around those objects. And so it's a different type of programming. It's substantially more powerful and more impactful when we start thinking about bigger solutions and bigger programs. So in terms of machine learning, I like to phrase things in terms of AI and machine learning, where we can think about functional scripting. Functional programming is like training a model to predict something at a point in time. So think of forecasting. We want to forecast what sales will be. You're going to give me this. I'm going to run a script on all your historical data, and then I'm going to forecast sales. That's scripting. That's functional programming. Or maybe you want to, instead of forecast sales, I had another one, sorry. I don't remember what it is, but forecast sales. We'll just go with that. You want to forecast sales, functional script, give me your data, I'll produce your forecast for you. When we think about object-oriented programming, there's something called reinforcement learning in AI and machine learning. And this is when you need a machine to learn over time. So give me information and then update how that machine behaves. And then perhaps then you have a machine or an agent, and that agent is interfacing with some type of environment, and that environment is storing results of what has happened in the past. And so the classical hello world example in machine learning for reinforcement learning is something called the multi-armed bandit problem. So to try to ground some object-oriented programming concepts into a real hello world programming for AI and data science of object-oriented programming meets Python, we're going to talk about the multi-armed bandit problem here at the end. Okay, but before we get there, we should probably talk about some key object-oriented programming concepts. Again, think of this as like a really high 10,000 foot level speed course on all of the nomenclature, terminology, and the top concepts I think you should focus on if you're going to study and you're going to explore object-oriented programming. So this is more like a how-to guide for what you should learn. We'll dive into examples. We'll play around with some code. We'll just try to hack some things out. But this is not all encompassing. And really the only way you're going to get familiar with this, I think, is if you just try it out and try to build some examples yourself. So we're going to talk about classes and objects, attributes and methods, encapsulation, inheritance, polymorphism, and why you should use object-oriented programming. And maybe where you shouldn't. But excuse me. I'm a little sick today, so forgive me. I do have a 2-year-old, so it's just kind of the state of life at this point. Object-oriented programming. Let's learn how to structure your programs using these principles. So what is object-oriented programming? It's a programming paradigm, and it's based on the concepts of objects. We're going to define things as objects. So this lecture, this content now ties back to the very first class when I told you guys everything in Python is an object. Now we're learning object-oriented programming. So that's why I started this course teaching you what objects are, because now I think you're placed ahead of the curve to learn object-oriented programming because you already understand objects. And I think what you're going to find is that you actually already understand attributes and methods as well. So this should be really easy for you to pick up. So anyways, object-oriented programming, it's a programming paradigm based off a concept of objects, which contain both attributes and methods. And the purpose of defining everything as an object is to organize and structure our code to make it reusable, scalable, easier to maintain. It's basically to structure our code so certain parts of our code can communicate with other parts of our code in ways that are efficient. We're going to talk about classes here in a minute. And what I want you to think about classes as like a blueprint for an object. Objects are built from blueprints, produced from blueprints. And so we have to define what that blueprint is in order to produce that object, just as an actual car is built from a blueprint. So the first thing we're going to talk about, the first concept first concept in object-oriented programming is classes. So this is the first new thing we haven't talked about in Python. What is a class? What is a class object? And this is not just Python, by the way. This is all programming languages, all star. Many programming languages have classes, define things as object-oriented programming languages can define things as classes. So Java has classes as well. So this is not just a Python thing, but this is how Python defines classes. What is a class? A class, think of it as a blueprint. We are telling, just like we create a function, and then we tell the program, run this function, we're going to define this is a class, and then we're going to ask the program, now instantiate or create this class. But first we have to define what that class is that we want to create. So we're going to create a blueprint or a template basically for generating classes. You can think of this like a factory or a template. And then once we have this template, once we have this definition, class definition, we can create as many of them as we want. So in this example, we're going to use dog. Let's think about dog. We're going to create a class for dog. We are going to define the things that make up a dog in our Python program. So initially, I forgot my mouse today. It's in all kinds of a day. So I am on my trackpad, so bear with me here. How do we create a class in Python? We're going to use this keyword, Python keyword here, class. And sorry, I just realized this is not displaying up here. I don't know why this. We're going to use this Python keyword class to define our class, and then we have to name our class. Just like in functions, we have to name our function. Here in classes, we have to name what our class is. So we're going to name our class dog. The semicolon indicates we're done naming our class. And then this is called our class initialization. And right now, just ignore this. You can just copy this word for word. Def __ init __ there's 2 underscores there. Open parentheses self. Don't worry about self right now. And it's going to take in one parameter. It's going to take in a parameter name. And then here we're saying self, which means, now I'll tell you what self is. Now we can worry about self. Self means just the object itself assigns to its attribute name the value of name. So we take in name, it comes here, we pass name here, and it gets assigned to self.name. So this is how we define our class. This is the blueprint when we say that we create a template or a blueprint. This is our blueprint. This is our template.
Are you drawing that by chance? Because you don't have a whole bit. I'm following you from the PowerPoint.
Yes. This thing is not working, so we'll just have to wait here for a moment till we get to the break. I am on the StreamYard, and it is being recorded. I am drawing on this, yes. And you guys can see on the StreamYard, right? Yeah, okay, good deal. Okay, hold on. Class. So this is our template, our blueprint for creating our class. And when we want to use that blueprint, so we created and defined this blueprint. We said, this is a dog, and dogs must have a name. And when you give me a name, then I'm going to assign that to my dog object, and it's going to hold that name. When we're ready to use that class and actually create a real dog, we didn't actually create a dog yet. We just said, this is what dogs should look like when you create dogs. Now we're ready to create a dog. So when we create a dog, this is the instance of the class. This is called instantiation of an instance. Here we're calling dog. Notice we can just call dog like you would call any other object or any other class. So you guys have actually been working with objects this entire time. And we have to pass in the name parameter. So this name buddy gets passed to this initialization, this class initialization. And now when we call, and remember, so we're calling this function, we're calling this class dog, and we're passing in this parameter to this name, and we're storing this class in the variable dog1. And now when we call dog1.name, we actually get the value out of buddy. So an object contains its own data. This contains its own name data with a value of buddy. And we can use this. This is about as simple as we can get for a class. Let me pause here for just 1 second. Any questions so far? Okay, let's look at some code. Let's try to maybe get a little hands-on with this. We get some. Well, my navigation is not great today on a trackpad. I'm annoyed at myself for getting my mouse. Okay. So if we want to create class, we're going to use the keyword class. We're going to say dog. And the first thing that we have to do is define initialization, which is going to be 2 underscores. Initialization will always take in the self parameter. So we always have to have the self parameter. And in this case, we're actually going to ask it to take in another parameter called name. Then to the dog object, when you create your dog object, the self.name, we're going to set to this value of name, this name that gets passed here. So if we want to define the class definition for dog, create an instance of dog, my dog equals dog Fido. So if we print out my dog, we can see it's a dog object. If we do type of my dog, we can see that it's a dog object. We didn't create any doc strings with it, and it gives us that our initialization takes in a parameter name. If we call my dog dot, we press dot, we can see we have only one parameter option. which is name. We run my dog.name, and we get Fido. Let's create another dog. My other dog, and we're going to call this dog Buddy. So if we call my other dog .name, now we get Buddy. Maybe we call my third dog, and this is Max, my third dog .name, and we're going to get Max. Now we do have to pass name because we defined name up here as a parameter to the initialization. So if we did my error dog equals dog, we get the dog.init missing one positional argument, name. Okay. Let's go a little deeper. Attributes and methods. Attributes are any data points associated with an object. So we talked about name. Name is an attribute of our dog. Our dog has name attributes associated with it. We could also add breed. We could add age. These are values that exist within the object.
Since I can't review the whole bit that I'm getting lost, but I'm following you through the PowerPoint, and for some reason my GitHub isn't working.
Okay.
So I'll be patient.
Okay. I think we're gonna keep going through this content because I don't want to derail the entire class. I don't know why this thing is flashing, but the click share is not working. You can't join on the StreamYard? You can't get on your Slack? All right. I can pause class. We can take a 10-minute break if you guys want, and I can help you get signed on here. Okay. Let's do that. We're gonna take a 10-minute break. If you guys could try to spin up in your own notebook a class, and try to spin up a class here and do something different than dog. Maybe define a cat and try to come up with an attribute that would be associated with a cat, and try to create a definition, a class definition for a cat. Okay. Give me one moment. We are back. Let's look at this. Let's try to look at an example for a cat. Let's create instead of def, let's create a cat class. And let's make the initialization of that class. Initialization, this is the function, sorry, that is called when you, this is the function that's called when you initialize your instance. So this here is called initialization. When you call your class, your object class, sorry, I'm getting a phone call. There we are. When you call your class here and then store that into a variable, that's called initialization. You're initializing your dog class with the name of Max into my third dog. When you do that initialization, the values that get assigned at that time are the ones that are defined here in the initialization function. So self.name equals name, self.color equals color. Let's do this and let's try to make a cat. So my cat equals cat. Garfield orange. If we call my cat, we see that it's a cat class. Type of my cat is a type of cat. If we call my cat dot name, we're going to get Garfield. And now if we call my class dot, you can see there's actually two options here. Before last time we just had name. Now we have name and color because we added a second attribute to the cat class. We added two attributes to our cat class. So that's what an attribute is. It's data associated with the object. And the way that you update and change that data is by calling self. So the way that you update and change that data is by calling self. Now, this is particularly important, by the way, if you want to get into deep learning. So if you want to do AI programming and you want to do deep learning, PyTorch and TensorFlow are object-oriented packages that build deep neural networks. And they are fundamentally based in this object-oriented paradigm. So when you create a network, you have to say self.layers, and you have to define the layers of your network. And when you define your activation function for your network, you have to say self.activation and define your activation function. So these concepts are important, particularly in machine learning and in AI. I think functional programming will only get you so far these days, and you really need object-oriented programming if you want to do deep learning and any like powerful AI programming. I think for traditional machine learning, functional programming will get you there, but object-oriented programming is the next level if you want to go further. So functions, these are attributes. When we talk about attributes, we're talking about these pieces here. When we talk about methods, a method is basically a function. Hey, you guys recognize this? It's the def. We're creating functions now. So methods are functions that define behavior of an object. So you can think of attributes as data. Tell me some information about an object. If you have a dog, tell me your name, your breed. Methods is what does that dog do? Well, the dog can bark. So the methods are actions or behavior that your class, that are related to your class. So when looks like we created a function here called bark. Bark takes in the self object and prints out self.name says woof. So it makes the dog bark. Let's look at an example. So here, let's just try that. let's define a method for dog. So let's have do this slightly differently. Okay, so we have our class definition for dog, our initialization function that takes in name and assigns name back to the self parameter. We have a function that takes in self, which is just the object itself, the dog in this case, and it prints out self.name says wolf. Let's try that out. So we have let's make a my barking dog equals Fido. We can say my barking dog.name, and we can say that the dog's name is Fido. Let's call my barking dog .bark. And remember, bark is a method. It's a function. So we have to end it in parentheses. So attributes, when you call them, do not have parentheses. Methods do. So there's end in parentheses here. And it says, Fido says wolf. Now let's create a different dog. My other barking dog. Attributes don't always have underscores. This is an attribute and it doesn't have an underscore. In this example, there's no underscores in name. The name is an attribute. There's no attribute. Attributes, that arrow is pointing to the attribute self.name, self.breed, name and breed. They can have underscores, but they don't have to. And in this case, they do not. So my barking dog, my other barking dog .bark, and now it says Buddy says wolf. So it doesn't, this one says Fido says wolf, and this one says Buddy says wolf. So the advantage we're getting here with classes is we're defining how a dog should behave and what attributes need to be defined to make up a dog. And we're getting that really consistent behavior. So if you've ever worked in a really messy functional programming script where you wanted to change one thing and then you had to change it in 10 different spots in your code, classes, this object-oriented programming, this hyper-structured way of telling you this is how your program has to behave becomes very, very useful. Okay, so that's it pretty much. If there was one thing I would ask you to take away and to focus on for classes, it would just be that. Classes, how to create them, how to instantiate them, what an instance is, what attributes are, and what are methods. That's classes 101. That's really everything that you need. Now I'm going to touch on 3 very advanced topics. So classes are advanced enough. Now I'm just going to highlight very briefly for you, and I probably won't go through a ton of examples because I think it's something for you to explore. I want you to explore on your own. So 3 very advanced concepts that as you do more programming with classes, you may come across on the internet as you're researching. And one is encapsulation. So encapsulation is building bundling of data attributes and methods that operate on the data into a single class unit. So encapsulation oh my goodness, I hope I can get through class today. We may call it early. Encapsulation protects the internal state of the object and prevents unintended interface. So when we're defining things, we may want to break out deposit and get balance into their own unique pieces of code and not wrap everything into one piece of code. Wouldn't it be really bad if somebody was trying to hack into our system and they could change the account balances when they called get balance by making deposits? We wouldn't want get balance to communicate with deposit if we're building up a account object, for example. So encapsulation is something to keep in mind. Inheritance is really, really cool. Probably one of my favorite things about object-oriented programming is inheritance. Inheritance allows these child-parent class dynamics. So we think about this very naturally as humans. Dogs and cats are both animals. And so there are some attributes. We talked about attributes. There are some attributes that a dog and a cat should share, such as a species, maybe. Or maybe there are some things that as animals, dogs and cats have in common. Well, we can have an animal class that is the parent class. And inheritance can be passed both to our dog class. Oops. There we go. And to our cat class. And so whether it's attributes or whether it's methods or functionality, it can be passed to both classes. So here we can see that dog actually inherits animal. We're passing this animal inheritance down to dog. And now, even though nowhere in this code did we say species, you can call dog1.species because it's getting that species attribute definition from animal. Even though we don't say self.species inside of the dog code because it's inheritance. That way, it's fantastic. That way you can build code once. I can just build code once in the animal location, and then I can use it multiple places. You don't have to rebuild species, or you don't have to rebuild some functionality. So that's inheritance, parent-child pattern.
Emily?
Yeah.
Emily?
Yeah.
How are we able to tell that the dog is inheriting animal? Is it the word super?
That's such a great question. Yes. The word super here means there's two ways. One is that we're passing animal here in this parentheses. And the second is that inside of the definition of dog, super is when we're calling the parent class. So super.init dog, we're passing in dog to this init function of super. This is what is bringing in the initialization of species into this class definition. So yes, dog is getting assigned to species.
Okay.
That's a great question. I missed that piece there. Thank you.
Okay, you're welcome.
You're tracking 100%. Okay, the third concept, if I was learning object-oriented programming advanced all over again, is polymorphism, which is the ability of different objects to respond to the same method in their own way. So just like in this previous example, we had animal and we had at a class level, we could share this with dog. In a similar way, think of methods. That was an attribute. This is a method now. And we've defined this method called speak. Each animal has some ability to speak. But the way that a dog speaks is different than the way that a cat speaks. So during the inheritance, what this is saying, when dog inherits animal, is we're just telling dog that you have to implement speak. You can't create a dog that doesn't speak. And when cat inherits animal, we're telling cat that you have to implement speak. You can't create a cat that doesn't speak. However, when you do implement speak, you can do it in your own way. So this dog implements speak and prints wolf, and the cat implements speak and prints dog. So if we create a list and we put two things in the list, dog and cat, an instance of dog and an instance of cat, we say for animal and animals, animal.speak. The first animal will wolf and the second animal will meow. So both the dog and cat can have different implementations of that. So those are the three main concepts: encapsulation, inheritance, and polymorphism. Again, I would focus mostly on just understanding what a class is, what an instance is, what a class definition is, initialization, attributes, and methods. Those are the main core pieces. Okay. Advantages of object-oriented programming. Why use object-oriented programming? Well, the code is organized into self-contained classes, and they're reusable classes and methods that can be reused across projects. It's scalable, and new features can be added a lot easier, and it's a lot more easier to maintain and debug and update. It is more complex, so I should have another slide that should say when not to use object-oriented programming, because I don't think it's great for all use cases, but maybe I'll do that next time. Okay, let's see. I have a very particular and very detailed example here called the multi-armed bandit problem. I do want to talk about it. I also want to do your homework, and I'm afraid there's going to be a lot of questions on that, and I do want to get to that. So I think we'll jump to your homework here, and maybe we'll take a short break, jump to your homework, and then if there's time at the end, we'll come back to this. I'll tee up what it is here in the definition so you guys are tracking and aware. So the multi-armed bandit problem is, imagine you walk into a casino. And it's a theoretical problem that there are these bandits. And bandits are what they used to call slot machines, by the way. So you walk into a casino and there's these slot machines there, and they're called bandits because they steal all your money. I know that slot machines are very complex today, but imagine a simplified problem where if you pulled an arm on a bandit, pulled the lever on the bandit, it's called an arm. You pulled the arm on the bandit. It had a static probability. So imagine one slot machine had a 70% success rate. Wouldn't that be fabulous? This is just a thought exercise. So it had a 70% success rate. So out of every 10 times you pulled that arm, it paid out 7 out of those 10 times. The thing is, when you walk into this casino, this gambling bar, there's 4 slot machines here. And originally, you know nothing about them. You don't know what their win rate is. So to you've not done anything to experiment or try. You don't know what their win rate is. But under the hood, they have a win rate. Like this one is 70%, this one is 30%, this one is 55%, and this one is 40%. So your goal, your objective is to find the highest winning bandit the fastest. If you had infinite tries, no problem, right? The thing is, imagine you only have 1,000 tokens to spend. How do you spend your tokens optimally such that you have found with confidence, with some degree of confidence, the highest rate payout bandit? So this is the Hello World problem of the multi-armed bandit problem, the Hello World of object-oriented programming. I've got some overviews here. So you're a player in a casino. However, this is no ordinary casino. It's composed entirely of slot machines. And furthermore, these slot machines have a predetermined static probability of dispensing a reward. And the payout is the same rate across all the machines, $1,000. It occurs to you that if you could find the machine with the highest probability of giving a reward, you can receive more rewards over time. This is your chance to finally beat the house. There's only one problem. You have limited resources. The slot machines only accept special tokens, of which you only have 1,000. You start to wonder, given your limited resources, how you might develop a strategy to maximize the amount of money that you leave the casino with. So this is the gambling game. So the multi-armed bandit, it's an oversimplification of the multi-armed bandit problem. This is a very well-studied problem. You can research it on the internet. There are many solutions to this problem on the internet. I encourage you to explore them. In the multi-armed bandit problem, there exists a subset of bandits, such as slot machines, which have some hidden probability of dispensing a reward. And during each round, the player can choose one bandit or arm to pull, and the selected choice will either dispense a reward or not. The goal, the objective, is to develop an algorithm that maximizes the rewards earned over time. So successful strategies can quickly identify the right machine or set of machines with the highest likelihood of reward. I decided I'm just going to go through these slides very quickly, as you guys can tell. How does the role of object-oriented programming play into bandits? Well, in encapsulation, we bundle the behavior of data into bandits, actions, and agents. So we're starting to define objects here. It makes it easy to test, extend, or replace our components, and it's scalable across environments. So there are classes by design in this problem. We just talked about classes, object-oriented programming. There is something called a bandit class, an agent class, and an environment class. So we talked about the bandits, the slot machines. So the bandit is your slot machine class. So it represents your slot machine and each arm of the bandit in the reward distribution. So you've got your slot machine, and how many times have you called that slot machine, and how many times have you gotten rewards from that? Your agent, this is what you're developing. This is your strategy. This is how you're going to choose which arm to play. So I'm trying to think of a clever picture to draw for an agent, but this is your robot. This is your machine that you're building. So this is your agent. And then your environment simulates the interactions between the agents and the environments. So this is what determines the rewards. All right. The only thing I want to highlight here is in reinforcement learning, there's a concept called exploration and exploitation. And if you're to explore this problem, one thing you have to explore is balancing exploration, which is trying out different arms and just discovering those probabilities, those reward probabilities, versus maximizing on what you've already learned and what you've already discovered. And so just choosing based on your experience of levers of arms that you've pulled, which one has the highest expected reward. That's exploitation. Class design. So if you look at the, I won't dive into this, but there is a bandit class and an agent class. So we just talked about classes. So here we have a class bandit, and bandit takes in a probability, and it has that static probability. So remember I said a bandit dispenses at a static probability. So every time you call pull on this bandit, then we say if this random number, this is how you do randomness in Python, random.random is less than the probability of this machine, then we're going to give you a reward. Otherwise, we're going to give you nothing. So this is all that's defined in a bandit class. It's pretty simple, pretty straightforward. It just has a static probability and it dispenses a reward. And we can spin up 4 of these. We can spin up 1,000 of these. We can spin up 10,000 of these. And this is why object-oriented programming is really useful. Because once you start to scale this problem, what I've seen is people will design a solution and it'll work really great for 4 bandits. And then halfway through the exercise, I'll flip it on them and I'll say, let's change 1 line of code and let's spin up all of a sudden 1,000 bandits. And does your strategy fall apart when we go to 1,000 bandits? And sometimes it does. So object-oriented programming, really great for this problem. This is the class design for agent. It's slightly more complicated. I won't go into it. But this is our agent class that is taking an action here. Agents have 2 things. They have to choose an arm, and then they have to update their rewards. Okay, I said I wouldn't go into it, so I am trying to. I think this is enough for this problem. I'm trying to think what other slides. So I talked about the paradigm of explore. I'm laying out 2 strategies here. If you're curious about exploring these strategies, curious about trying out some of these strategies. Explore only demonstrates the data science concept of what if we just never exploited anything? What if our agent action was just to return a static selection for action every single time? We just tried a new arm every time our environment asked, hey, agent, try an arm. We just tried the same one. That's explore only. Now, what if we exploited only? And every time we just chose the arm with the most optimal probability. Think about the consequences of both of those strategies. And I think you'll quickly come to a conclusion that you need to do some combination of explore and exploit. Okay, class design. What's an environment? An environment just says how these things behave together. So an environment takes in bandits and agents. So it takes in our bandit class and our agent class. And then it says, this is how the game is played. It says run simulation. So this defines how the game runs. It says 4 range in rounds. So for however many rounds we're playing this, 1,000 rounds, I'm going to ask an agent to choose an arm. And then I'm going to get the rewards from those bandits. I'm going to update that agent. And then I'm going to calculate the total reward. If you want to run this as a simulation, this is how you would do it. You would define your bandits, you would define your agents, and then you would run your simulation. What's really cool about this paradigm and the way of doing this is that we can create a simulation without ever having done something in the real world. And we can theoretically test out strategies that might work. And I've done this in real work, in my real work career. I have created object-oriented reinforcement learning solutions to test out strategies that might work before we deliver those strategies to customers, before those hit the web page, before those letters went out in the mail. We actually built simulations, founded things in assumptions, and defined strategies tested over many, many simulations. So I think what's really powerful about object-oriented programming and reinforcement learning is you can actually design simulations that will, you can design simulations that you can test out different strategies, different mathematical strategies and approaches for how to maximize rewards before you actually run them on real people, which is pretty neat. So I have an entire GitHub repository dedicated just to this. So it's really easy for you guys to play this game. I have instructions on how to do this. If you're interested, I'm happy for that to be a resource to you guys. You don't have to spin up all this code yourself. I have all of this inside of a code. All you have to do is run this one line of code. You just Python run game.py, define your number of bandits and define your rounds, and it'll play the game for you. And then you just tweak your agent. You can make your own agent, add it into the game, and just tweak it, and this game will run for you. So if you want to play around with this, I think it's a great way to step into the waters of object-oriented programming.
Is that dash,
Yes, -- bandit space 3. Okay.
bandit, space 3.
Yep. Let's take a 10-minute break here. We'll come back and we're going to do assignment 1 submission. 7:28. we're talking about getting hands-on with Python and how, yeah, maybe we've talked about a lot of concepts in this course, and they're useful, but the concepts will really only get you so far. And ultimately, at the end of the day, there is nothing that I can stand up here and say that's going to substitute you guys trying it out and getting your own hands-on experience. And yes, the homework is supposed to force some of that. And yes, the you would try it exercise is supposed to force some of that. But at the end of the day, it's you guys wanting to dive into the language and try it out. Something that helps me is I like to try to make Python programs that solve things in my life. And so I'm very interested in national parks, visiting all the national parks. And I'm going out hiking actually starting Saturday at a new national park, and that's why I will be out of reach for the next week. And one thing that I just thought, oh, it'd be fun if I want to practice some Python programming skills. I want to make a list of all the parks I've already been to, all the parks I have yet to go to, and then I want to put those as little pins on a map, and I want to see highlighted in green the ones I've been to, highlighted in brown the ones that I haven't been to, and then I want to see that map pulled up, and then I want to, that way when I'm planning a trip somewhere, I can see what national parks are nearby that I haven't been to yet. I can see my radius from Nebraska, what's the closest one to drive to that I haven't been to yet. And so I gave myself my own problem requirements and designed a little Python program that made that map for me. And I'm sure there's enhancements that I can do on that. It was a really simple Python program. It probably took me under 30 minutes to do. But it was really fun, just a way to solve a problem that I had in my life with a really simple script. So I think that's a good way to keep your skills fresh, to practice your skills. There's something that's like a small problem you guys have in your life. Try to make a little Python program to solve it. It's more interesting probably than a way of exploring the language than creating a dog class or creating a dog class. Like, try to make the language real to you. And then learn how to self-solve. So you come into a problem, you face an error, go to the internet, find the good resources, Stack Overflow, Data Science Stack Exchange, find the good websites that are going to give you good advice. AI is okay. Sometimes it makes mistakes. All right. Let's go through assignment submission. Let me pull up. So if you go to your Slack channel, I have all these detailed out in, we're going to both walk through this together, assignment 1, and I made a extremely detailed screenshot by screenshot. I don't know how many steps. There's a many page document, 11-step document for how to submit an assignment. So I hope this is helpful. If it's not, let me know what steps in here I should update or change. Step 0 here. Assume you guys have already done this. You made your Google Colab account. You're already registered. So I called that step 0. Step 1, make sure that you go and accept the assignment link. So somewhere in Slack, usually pinned to the channel, there should, under the pins, there should be a link for the assignment. I actually don't have a link for assignment 1. One moment. I will get the link for assignment 1. Okay. Or maybe I do have assignment 1. Oh, I do have the assignment 1. Okay. I just didn't pin it. I'll repost it because I can't find it. Assignment 1 link. And I will pin this to the channel. All right. So you're going to click the assignment 1 link. If you haven't accepted your assignment yet, you might see your email here. So when you come in here, just make sure you accept your assignment. If your name's not there and you still haven't accepted your assignment, you know you don't have an existing link out there, you can click skip to next step. Then click accept this assignment.
That's how I email you.
And then direct to this repository. And maybe next class we should do a TA to help with this or something. But in here, you're going to go to your assignment 1, calculators, and take that assignment that I uploaded to you guys in the Slack channel, click add file, click create new file, here we go back to our we have our Python programming assignment 1. We're going to download this. This is what we worked on last class. We worked on our assignment 1. We're going to click add file, upload file, choose a file. Python programming assignment 1. Open. We're going to commit changes. And now we can verify that we do in fact see our Python programming assignment 1 notebook in here. Yours should actually have code in it. This one doesn't have any code in it. This is an empty one. So that's how you guys submit your assignment. I've got the detailed step-by-steps in here. GitHub Classroom, accept assignment, save the URL, find your assignment repository, download the notebook. You should already have it downloaded and completed for assignment 1. Save the notebook into Google Drive. Open the notebook in Google Colab. Make necessary changes to your notebook. Save and download your finished final notebook. Delete the starter notebook from your GitHub repository. The blank notebook, if there's a blank notebook there, delete that, not to be confused with your new notebook. Add the new notebook, this is deleting the notebook. Upload your new notebook. So create or upload file here, this upload file button. Click choose files, go to your downloads, choose your most recent downloaded file. Finally, commit that to GitHub. And verify that your notebook looks correct in the repository. And you're done. Your homework is now properly submitted. Okay. Any questions? Homework submission. All right, last topic for today then. We're moving right along.
Of course, I have a question for you.
Oh no, you can ask now.
Well, so I'm at Python programming
Yeah.
And I went to the highlighted Python standard library assignment.
You went to the what?
You make these libraries for the Python standard library.
Okay.
That was Crystal Brown.
That's part of the directions for the assignment.
But you highlighted something else. Of course, the library is not discussed.
I highlighted something for what?
I mean, not highlighted, selected.
I don't know what you mean by selected.
So,
I'm missing something here. I think if you just follow the steps in this document, you should be good. And I took a screenshot of every single page.
and the line, but again, I can't get into that. I can't even see that.
The document here,
Yeah.
it's in the Slack channel. Okay. We do use the Slack channel for communication, so we do need the Slack channel access. Can you email Crystal and tell her that you don't have Slack access? They said what?
It's in an error.
An error?
Yeah.
Okay. I don't know how to fix the Slack channel error. I'm sorry. I would email Crystal because she does all the course coordination and she submits all the students to the Slack channel. So if you can't get into the course Slack channel, Crystal would know how to get you into the course Slack channel. You are in? Do you want me to email her?
Yes, because I didn't. Remember we sat here. and
Yeah.
I had Python programming assignment, but I can't get inside this.
I will email Crystal and I'll add you on there and see if she can help you figure that out. Yeah, because I just make the posts on there and we'll make sure I'll direct her your way. Make sure you get added in there because that is where all the links are for the assignments.
Remember I pulled them and I bookmarked and I'm going to my bookmark and it's coming back in error. We watched me bookmark everything and slide it over all my assignments, etc.
Yeah. I know what you're talking about. You're saying that you have the assignments in your Google Drive, but the piece that you need is you need to upload and submit your assignments to actually be graded on that. And you have to do that through GitHub because that's how we do our assignment management. And to open your GitHub link, you need access to the Slack. So you're going to have to reach out to Crystal and make sure that you have access to our Slack channel. Okay. Let's do assignment 2, Python programming, data analysis, exploratory data analysis, and visualizations. The goal of this is for you guys to do some independent exploratory data analysis on a real world data set. So try to create some visualizations using Python as a programming language. So now that you're tooled, you understand Python, you know how to use it, you should be able to pick up a data set and apply some EDA to a data set. For this, we're going to use the Titanic data set, which contains information about, are we using the Titanic data set? Yeah, okay, good. Which contains information about passengers on board the Titanic. I think the Titanic data set is a Hello World kind of data set that you could work with. The great thing about it is it already exists in the Seaborn package, so we don't have to do any really complicated download this file, upload this file. In this course, I really tried to minimize that for you guys so we can have as few complications as possible and just straight focus on the programming. So we're going to use the Titanic data set. It's a very interesting data set. It has all the people who are on the Titanic and it contains information of passengers, their demographics, their ticket class, and whether or not they survived the Titanic. So your instructions are to load the data set, perform some basic EDA and answer some questions here. So, how does survival rate vary by passenger class? What is the distribution of ages among passengers? And are survival rates different between male and female? And how does the survival rate for passengers differ for family aboard, for families aboard? As a bonus task, you can explore multiple relationships between these variables or create a heat map. And then finally, submit your work following those steps. So this is your goal. This is your directive. You want to get to answering these questions. The first thing that you guys should do when you're working with a data set is try to understand it. So I'm starting to say these things like P-class and SIB, SPD, P-arch. I don't know what those mean. We're going to have to go explore that. We're going to have to self-inform. We're going to have to self-explore this. So here I have some example starter code for you, just loading the data set for you, we're loading the data set from Seaborn. In order to do that, we're going to import our packages here. We're going to import Matplotlib. We're going to import pandas. We're going to import Seaborn. And then from Seaborn, we're going to call load dataset, and we're going to load the Titanic dataset. And here, I should have broken these into multiple lines. So let's call a df.head. Let's see what our dataset looks like. Here we have whether or not somebody survived. We have this thing called P-class. We have this thing called, we have the gender of the individual. We have their age. So this is interesting. This was a male, and they're 22 years old, and they did not survive. This is a female, and they were 38, and they in fact did survive. So now we can look at the fare that people paid for 71 versus 7 versus 8. We can look at if they were first class or third class, where they embarked from. So if we want to learn more about the Titanic data set and what this information represents, the first thing we can do is we can go to Kaggle, which is a website for data science problems and competitions. And we can start to look at a description for this data set. So it says, sinking of the Titanic, one of the most infamous shipwrecks in history. And on April 15th, 1912, during this maiden voyage, it collided with an iceberg, and it caused the death of 15,502 passengers out of the 2,224 passengers and crew. So in this challenge, in this data science challenge, they're having you build a predictive model. But the metadata here. But here we can start to look at the column values here. This is a different way of seeing this. What's nice about Kaggle is they give you a representation of you can start to look at the distribution of these column values. So maybe something that you might want to look at in your notebook, look at producing in your notebook, is a distribution like this for some of these things. For example, we can create a distribution of age, a bar chart for age to show the age. Let me go back to our Python programming assignment. So we took a look at the first row. So the first thing I would encourage you to do is to explore more, read more about the Titanic data set. Just Google the Titanic data set. It will come up online, and learn more what these different columns mean. So we did this, displayed the first few rows of our data set. I want you guys, we talked about shape last time, so I won't show you how to do it here, but I want you to print the data set shape, the columns, and some summary information and describe methods. I want you to check for missing values in the data set, and then try to create some visualizations on passenger class. So let's try to answer this one today. I'm going to copy this down. So I'm not going to do 2 for you, but let's do a couple of pieces in 3 because I think those are more challenging. So let me see if this is going to answer our question here. If we look at if we create here a bar chart with 2 categories, whether or not somebody survived. Survived is 1. Not survived is 0. Let me make sure that's correct. Oh, that's how we're calling it. Okay, so on the left here we have count, and on the right here we have P class. So if P class is 1, we can see that representation, there's a slight disparity for people of 1 to have survived, to been more likely to survive than, people of 0 or people of compared to 2. We pop to 2 here for P class. It's almost equal. It's like a coin toss, whether you're going to survive or not if you are in P class 1, or P class 2. But if we look at P class 1, you're much more likely to survive. But here, this is very interesting. As we jump to P class 3, you're very likely to have not survived. So P class is probably a very powerful feature to predict survival on the Titanic. Another interesting one that I want us to look at here. Let's create the same chart. But instead of P class, I want to separate on gender. Oh, very interesting. So if you are a male, you're much less likely to survive than if you are a female. Why do you guys think that is?
Women and children first.
There we go. Women and children first on the boats. And so in a predictive model, I imagine if we put these in as features into a predictive model, that gender, that sex in this case, would be a very predictive feature. Women and children first. So men are much more likely to not survive the Titanic. Here, let's see what else we had. Let's look at the distribution of ages among passengers. We looked at that, I think, in the Kaggle. This is a pretty straightforward one. So these might just be questions that you're asking of your data set. Let me see what this quickly gives us. Here we go. Distribution of ages. So a lot of people fall into this. We got a long tail here. A lot of people falling into this bucket here, but also a lot of children. It looks like people between the ages of 0 and I don't know, maybe 5. A lot of children under 5, apparently. A lot of babies. Let's look at one more here. Oh, we looked at the survival rates between male and female. We already did that. Are the survival rates different for passengers with a family aboard? Are the survival rates different for passengers with a family aboard? So here, we again, blue is did not survive. If somebody's really good at plotting, maybe you could make these colors more interesting versus survive, did not survive. So it looks like survival is our orange bar here. And if it's just one, so family size is one, you have a high likelihood to not survive. The blue bar is higher than the orange bar. But as soon as we pop up to a family size of 2, you have a higher likelihood to survive than you do to not survive. And that trend really continues through 3 and through 4. But until you get to 5, from 5, 6, 7, 8, and 11, your likelihood of surviving actually decreases. Why do you guys think that might be?
The livelihood decrease.
Maybe because they said you can only send some people in your family.
Yeah, that could definitely be. Not everybody can fit on the boat. You know what I would be doing if I was there with all my family? I'd be looking for them. I'd be trying to find them all, even if, maybe I didn't realize the direness of the situation. And yeah, so I bet these 5, 6, 7, 8, 11 are trying to find all their family members and maybe running out of time. This is such a morbid data set. This is awful. This is so sad. I need a more uplifting data set. This is a very famous one, though. Kind of fun. Awesome. So here's a couple visualizations. You guys can definitely copy and paste these, use these. I just ask that you try out the summary statistics here and checking for missing values in the data set. And then feel free to go ahead and submit this assignment, follow the steps that we laid out. All right, I'm going to stop the recording for today and then ask if you guys have any questions.